All right, so this is day 6 of notes, and it's day 6 and 7 of practice. Basically, it's just, we're going to combine it into one, so it's really only one set of notes. But it's all about proportional parts and triangles. So, when 3 parallel lines cut 2 other lines, they cut them proportionally. All right? So there's a ratio going on. So Fn, which is this small piece here, is proportional to NO the same way AL is proportional to what? LC. Okay? And then Fn, which is a small piece, is proportional to FO, the whole thing, the same way AL is proportional to the whole thing, AC. So small to big, small to big, small to whole, small to whole. Hey, now, you're going to have some fun here. This one's actually kind of nasty, so we're going to cross it out. Have some fun with that. It doesn't work out very nicely. So, you can set up a ratio here, and here's a little trick too. Watch what you can do when you have this situation. Fraction bar equal. Boom! You're done. Now watch how this works. 14 over 5 equals 18 over x. 14x equals 90. X equals 90 over 14. And you can just leave it as a fraction if you want to reduce it, but you don't have to change it to a decimal. Okay? If you change it to a decimal, you're going to get a long, nasty decimal you have to round. So I prefer you just stop here and leave it like that. Watch, here's another trick. You can also do it this way. 14 over 18 equals 5 over x. And look what you get. 14x equals 90. The same thing. And the reason it's the same thing is because it is exactly a proportion. The ratios are the same, no matter which way you set it up. So you have options. I usually think the easier one, though, is just to do this, because it's kind of like right there. That might be the easiest for you to see. Okay, if a line is parallel, it's called the side splitter theorem. If a line is parallel to one side of a triangle, so, we have a triangle here, and then you have a line that splits it from side to side and is parallel to one side, then it divides the other sides proportionally. It doesn't always have to be the base, okay? It could be like this. And this one is parallel to this one. So as long as it's a line parallel to one of the sides of the triangle. Let's go with this a little bit more. So AD, right here, is proportional to DC. Right? The same way, AE is proportional to what? EB. Okay? Over here to the right, AD is proportional to AC. So small hole. Now notice, we're not doing AE and AB. We're doing over here DE. Whoops. I want that to be green. DE is proportional to CB. So the small to the whole, small to the whole. And over here, this is probably the most challenging one. Is we have AD, oh, not this one, sorry. AD to AC. Okay? And then we can just say over here, this is actually the easier one, AE to AB. Small to whole, small to whole. This one over here is the more challenging one because it involves the parallel sides. All right, just a little bit more of the same. So CD, right here, is proportional to DE. So big to small. The same way that CG is going to be proportional to what? GF. So, you know, if you want to do, like we talked about before, stuff like this, that helps some people. All right. ED, small piece, to FG, small piece. And then we have GC, big piece. So what's missing here? DC, big piece. So again, we'll put small and big, if that helps you, go ahead. Okay, these two at the bottom are a little bit more challenging. So we have CF, which is the whole thing. And over on the other side, we have CD, which is the big piece. That's on the bottom. Okay? So you have, on top, here you have the whole, and down here you have the big piece. Whole, and the big section. So, what is the big section of CF? That would be CG, and that's why these labels come in handy. And what's the whole of CD? That would be CE. So, something really helpful to have this. All right? All right. GD, what's that? GD is right here, and FE is right here. Okay? So, GD, CD, if we went this way, so FE, CE. All right, just some more examples we're going to do here. Do a little math here and solve. So again, remember, you have two tricks here. You can make a fraction that equals that, or I think the easier one to see visually is x over 16 equals 5 over 12. And you literally just write that. X over 16 equals 5 over 12. Then you cross multiply. And you're going to get 12x equals 80. X equals 80 over 12. And just don't do it as a decimal, just reduce the fraction. So what goes into both? 4. How many times? 20 times and 3 times. And you're done. Just leave it as a fraction. There's going to be a repeating decimal if you don't. All right, on this one. So we have 4 to 5. Okay? Well, the 4 is going to be the the 8 there. And this x goes with 5 on the bottom. Now we just solve. Now some of you might see right away, oh, this is just double times 2. So this is going to be 10. If you see that, shortcut, you're done. Otherwise, it's 4x equals 40. Divide by 4, x equals 10. Right, so got some more examples. These are just more you're going to be able to use for your assignment to help you with examples. So again, I like to just do this over this, like so. Makes it very easy. So x plus 1.5. Remember, anytime you have a binomial, put in parentheses, please, over x equals 5 times 3.5. So now you're going to distribute. Alright? So you're going to do 3.5x, but then you got to do 3.5 times 1.5. And that's plus 5.25 equals just 5x. Now you're going to subtract 5 by 3.5. So you're going to get minus 3.5x, minus 3.5x. And yes, it's going to give you decimal, but we kept decimals anyway. Over here, 5.25x equals 1.5x. And now you just divide by 1.5. So 5.25 divided by 1.5 is 3.5. And we're done. Okay, so I'm going to solve for x first, right? So 3 over 5 equals x over 4. So, cross multiply and solve. 5x equals 12. X equals 12 over 5. You're done. Don't have to turn it into a decimal. You just leave it like that. Okay? And then, for y, 6 over y equals 5 over, we need the whole thing here, so that's 8, like so. Now we could use this side also, but that would mean putting 12/5 in here, and it's much easier to deal with 8 than, a nasty fraction. So that gives us 5y equals 48. Divide by 5, y equals 48 over 5, and you can just leave it like that. No need to turn it into a decimal. And it won't reduce. And that's it. Or not. You have an extra page. So we're not going to do all those. I'll draw a couple of these out. So how about the left one in the middle? So you have 12 here and 32 here. I want to show you this one because there's a nice little trick to this. Since you know the whole thing at the top is 32 and this piece is 12, all you have to do is subtract and find out this is 20. And then you have your, that equals that. So 20 over 12 equals 35 over x. So you get 20x equals 35 times 12, which is 420, and then just divide by 20, and x equals 21. That's it for that. Okay. How about the one right next to it? we have 3, 4, and we know this is 14, and this is what we're trying to find. Well, another cheat. Since you know this whole side is 14, you can figure out this whole side is 7. Okay, so when you set up your fractions, you put the whole on the bottom. We're looking for this piece here over 14, and that means we're looking for this over here, and now we just cross multiply. 7x equals 42. Divide by 7, x is 6. Let's do this one. So we have 12 here, we're trying to find this, we have 15, and we have 25. Well, we're trying to find the big piece down here. That means we need this total here, which is 40. And now, we just do 12 to x the same way 15 is to 40. Now we just multiply. So 15x equals 40 times 12, which is 480. Divide by 15, x is 32. Now we'll just do one more here. 14, 20, this is similar. We know this is 65, and we're trying to find this. Well, this is just like the other one, except this time we have the whole. And we're looking for a small piece. So again, the 20 and 65 are going to go on the bottom. The 14 goes with the 20, the x goes with the 65. And now we just cross multiply and solve. If I get the board to move up. I guess I can't. So 20x equals 14 times 65, which is 910. Now we divide by 20. X is 45.5. And now that's it.